Good morning students. Today we are going to discuss problem related with the Morse test. During trial of a 4-cylinder 4-stroke SI engine running at 50 revolution per second, the brake load was 267 Newton when all cylinders were working. When each cylinder was cut off, in turns and speed returned to same 50 revolution per second. Brake reading were 178 Newton, 187 Newton, 182 Newton and 182 Newton. Determine brake power, indicated power and mechanical efficiency of the engine. For brake, BP is equal to F into N divided by 455 kilowatt, where F is the brake load in Newton and N revolution per second. The following results were obtained. Fuel consumption 0.568 liter in 30 seconds. Specific gravity of fuel 0.72. Calorific value of fuel 43,000 kilojoule per kg. Air fuel ratio 14:1. Exhaust temperature 760 degrees Celsius. Specific heat of gas 1.015 kilojoule per kg. Water inlet temperature 18 degrees Celsius. Water outlet temperature 56 degrees Celsius. Water flow rate 0.28 kg per second. Ambient temperature 21 degrees Celsius. Draw up heat balance sheet in kilojoule per second. So in this problem we have to find brake power, indicated power and mechanical efficiency. Also, we have to draw heat balance sheet. For calculating brake power, they have given the formula BP is equal to F into N upon 455 kilowatt. Here value of N they have mentioned in this problem. N 50 revolution per second they have mentioned. So for calculating brake power, we are using brake power is equal to F into N divided by 455. When all cylinders are firing, F in Newton, they have mentioned 267 Newton. So we are going to substitute this value 267 into N 50 revolution per second they have given. So we are going to substitute N is equal to 50 upon 455. So we got brake power when all cylinders are firing 29.34 kilowatt. We know that indicated power is equal to 4 into BP, means when all cylinders are firing, the whatever the brake power minus when first cylinder cut off plus second cylinder cut off plus third cylinder cut off plus fourth cylinder cut off's brake power. So first we are going to calculate BP1 F into N divided by 455, where F 178 and 50 divided by 455. So BP1 we got 19.56 kilowatt. BP2 F into N divided by 455, 187 F they have mentioned. So after substitution we got BP2 is equal to 20.55 kilowatt. BP3 F they have given 182. So after substitution we got BP3 is equal to 20 kilowatt. For BP4 F is equal to 182 Newton. So we are taking BP3 is equal to BP4. Now we got all the brake powers related with the respective cylinder cutoff. Now we are going to substitute the values to calculate the indicated power. So indicated power is equal to 4 into BP, which is 29.34, minus into bracket 19.56 plus 20.55 plus 20 plus 20. So we have substitute all the values. We get indicated power is equal to 37.25 kilowatt. Hence we have find brake power and indicated power. Now we have to calculate mechanical efficiency. For calculating mechanical efficiency, we have the formula brake power is equal mechanical efficiency is equal to brake power upon indicated power. So after substitution, we got mechanical efficiency is equal to 29.34 upon 37.25. We got mechanical efficiency 78.76%. So we have calculated indicated power, brake power and mechanical efficiency. Next, they are asked to calculate heat balance sheet in kilojoule per second. So, first we have to calculate heat supplied. For calculating the heat supplied, we have the formula MF into CV, mass of fuel consumed they have mentioned, and calorific value they have mentioned. So, for calculating mass of fuel consumed, we have to substitute 0.568 into 10 raised to minus 3 into 0.72 into 1000 upon 30. Why we have taken this? Because they have given this fuel consumption for 30 seconds. Specific gravity they have mentioned. For 30 seconds how much fuel is consumed they have given the values. So we have to convert for per second of fuel consumed. So we have substituted these values and we got the mass of fuel consumed. Calorific value 43,000 they have given. After substitution the values, we got heat supplied is equal to 586.2 kilojoule per second. Brake power we have calculated initially. Brake power is equal to 29.34 kilojoule per second. While calculating percentage wise, we got brake power in percentage 5%. Heat to the cooling water, we have the formula MW CPW into delta T. So MW mass of the water they have given 0.28, CPW 4.187, water inlet temperature 18 degrees Celsius, water outlet temperature 56 degrees Celsius. So we got delta TW is equal to 56 minus 18. So after substituting all these values, we got heat to the cooling water is equal to 44.55 kilojoule per second. Percentage wise 7.6%. Now we have to calculate heat to the exhaust gases. While calculating heat to the exhaust gases, we have the formula mg into cpg into temperature of exhaust gases minus atmospheric temperature. So first we have to calculate the mass of gas. So we got mass of gas is equal to 0.204 kg per second. So we have find this mass of gas as we have discussed in the previous problems. Now so after substituting all the values, mass of the gas 0.204, CPG 1.015, exhaust gases temperature 760, atmospheric temperature 21, we got 153 kilojoule per second. So percentage wise 26.1%. Now we have calculate brake power cooling water heat, exhaust gases heat. Last, we have to calculate unaccounted heat losses. So for calculating unaccounted heat losses, we have to take the difference between the heat supplied minus heat utilized to break power, cooling water and exhaust gases. So after substituting the values, we got unaccounted losses is equal to 356 kilojoule per second. So percentage wise 61% we got. Hence we have plotted the heat balance sheet. We can substitute these values in the heat balance sheet and we draw the heat balance sheet in terms of kilojoule per second. Hence we have completed all the problems related to the performance parameter of the IC engines. In next lecture, we are going to discuss supercharging and turbocharging. Thank you.